So hello everyone, today we are discussing about the climbing a stair question of LeetCode. That's question number 20 of climbing a stair. That's climbing a stair, and that's the first example is if n equal to 2, that's return output. And what is the I have to do in here? So you are climbing a stair. It takes n step to reach the top. So this is my first priority to reach the top of the stair. Now, so how can we reach the top of the stair? So each time we can either climb one or two step. So you have to think. So now at the time we can take only one step, either one step or two step. Got it? So how can we reach at the top of the stair? This is my question. If you have a two step only, how many way to can reach at the top? That is two. Either you can take one step, either you can take two step. So for the three, check there are three ways, either 1 plus 1 plus 1, 1 plus 2 and 2 plus 1. So I will add all the combination. So in that one, what should I do here? Check it once. So now we are discussing about the climbing the stair. This is your first way. If you have a n equal to 0, n equal to 1 and n equal to 2. This is my first example. It takes one step. It takes one step for one step. If you have only one step, that is okay. If you have only two steps, so in this one having two step. So now check it once. Just copy, paste, not working here. Again I have to write here one step. That is one step and two step. That is my question. So we can done through the recursion, we can done through the DP, that is a dynamic programming. In dynamic programming we are done by two ways, that's the memoization and tabulation. So in that question we are done through three ways. So check it once. How can I achieve this answer? And check the test cases that I have. First I have to combine all the ways. Suppose if you go with the one step, so how can I call the another one? Climb stairs. So if you think, if you go with one step, let's see if you add a 2, right? If you add a 2, so in that one either we can move 1 plus 1. If you take only one step like that, check it once. If you only take one step, that's here. If you take only one step, you will call either 1 or either. So it means that this is nothing but a n minus 1 and this is nothing but a n minus 2. Okay, now it comes to the 0 part, but this n minus 1 again it call one another function that is there, n minus 1, and it reached to the 0. So now 0 is my base case. How can I handle the base case? how can I handle the base case? If you go with like that, there is a one step, there is a one step, and this is directly two step. So if you n equal to 0, suppose if you have a no any step, how many way to reach? There is one way. If you, this is my base case, this is my base case, this is my base case. So it return 1 to upper 1, it return 1, it return 1, it also return 1. Okay, and it also return 1. So how many ways having to solve this answer? That is a 2 ways. So now then I have to go with the climbing stair, we call n minus 1, and also add the way. And how to go with the second step? Climb stairs n minus 2. So I have to combine all the ways, right? So I have to return all the ways, and we have to return same. But how can I handle the base case? Base case is nothing but this part. If you n equal to 0, this is my base case. How can I handle it? You have to go with the, if n equal to 0, or if you go with the n lesser than equal to 1, then you have to return 1. You have to return 1. Run it. So this is some syntax error. Unchecked once, there is no any certain error here. Climb stairs, spelling the same, n minus 1, n minus 1. That is okay. If n equal to 1 or lesser than 1, then you have to return 1. So now check again. So all the conditions get accepted. So now if you submit the answer, let's see, time getting exceed. Check it once. Time getting exceed. That's time getting exceed. So how can I manage it? So this is my problem, and let's see, out of 45 only 31 cases is getting passed, but I have to handle through the DP now. Check it once how it getting optimized. So let's see, if you go with the same thing, if suppose if you have a 4 step or 5 step, suppose you have a 4 or 5 step. So if you have a 5 step, what is the problem? You have to check it once. If you have a 5 step, that is called another 2 number. So 5 call 4. If you go with the n minus 1, that is a 4. If you go with the n minus 2, the 5 call 3. Again, this is the same scenario for that one. Okay, if you go with the 4, call for n minus 1, that is again 3, and if you go with the n minus 2, that is 2, like that. So now if you go with the n minus 1, and left side n minus 1, right side n minus 2, that is n minus 1, and that one is a n minus 2. Again this side 3 also done for the n minus 1 and n minus 2. If you go with the n minus 1, there is a 2. For n minus 2, there is a 1. So now if you go with like that, there is a tree like a structure. Clear? Now check again, there is another one. If you come to the 3 also call another 2 sub leaves node. If you go with the n minus 1, 3 call 2 and 3 call 1. That is there. If you go with the 2 call another 2 sub node, that is 1. If you go with the n minus 1, and this is 0. So now you have to think here, this is n minus 1 again, and this is n minus 2. Okay, now we can move for the 2 again. It call another 2 subnode, that is 1 for n minus 1 and for 0 for n minus 2. This is nothing but a n minus 1 and this is n minus 2. Clear? Same here, n minus 1 n minus 2. So left side always call n minus 1, for right side it always call n minus 2. For this is n minus 2, sorry, n minus 1 and this is n minus 2. So now check what is the repetitive work is here. 3. We also call 3 here and also here, right? This part is a repetitive part. This part is a repetitive, right? And same, this part is a repetitive. Now check, this part is a repetitive and this part is repetitive. So all this part again repetitive, right? So same solution we call multiple times. Already I found the solution, but again I will call it. So this is a drawback of the recursion. So now what will we doing here? We are done the same question through the DP. That's using memoization. So now check how to do in memoization. We stored the result of the solution of already done operation. Let's see, already we done calling of 3 which call 2 and 1. So we solve the solution and stored in a DP. Okay, let's see what will be happen here. In that one I have to go with the same operation, but we have done through the DP. Okay, now check it once. Here we have to call the another DP. So first I will create the DP int DP with new int, and so I have to go with the n size DP. There is an n size DP, and next one I have to fill all the DP with -1. So what should I do here? Either we can go with the for loop, or we can go with the predefined method, that is arrange dot fill, and we pass that's dp and -1, that is there, and return the a method which are not declared now, but I will do it after that. So if you go with public int ways and int m and int dp with array, so now we call the same wage which is n-1 plus wage of n-2, and we are stored into the dp of n. So dp of n contains all the solution of dp of n-1 and dp of n-2. And what is the base case? Same, if n is less than equal to 1, then you have to return 1. Okay, if dp is not equal to -1, that time you have to return the value, means we already calculate the solution of that number. Clear? So check it once. If you have dp is dp of n not equal to -1, then you have to return the dp of n, means exact value, already calculated value. So now check it once. Then after, in last, we return dp of n. This is my dp question. Oh shit, I've done some error. Like, let's see, I'm not assigning the square bracket here, means it not recognize this is an array. Clear? So I have to go with again wage 1. So method wage solution is applied given the types. Okay, dp of n-1, dp of int. Oh, so we are not calling with dp. So that's wage contains 2 parameter, and I'm passing only 1 parameter. That's the problem. This is a common mistake. And I have to call it with so why we're not getting the n-1 that is there? Oh, I have to go with the n-1 now. I have to go with n+1, and that is all. Now it's getting solved. Check it. Now it beat 100% with 0 millisecond. That is okay. So what will happen here? First, I will pass the dp, which is fill up with the -1. Means first I have to calculate the dp and with n+1. So in that question, what is it? How many n is there? 2. Means I have to create the dp with 4. 2 or 3. That's 0. That is 1. That is 2. That is 3. So all are filled up with that is 0. That is 1. That is 2. That is 3. that is 3 is there, no? N plus 1, that is okay. So now all the numbers, all the DP size is filled up with the -1. Go with the -1. -1. So all are filled up with the -1. So now what will we have to do here? So all are filled up with the -1, and I have to fill up with the answer or solution. So when I call with 3, so check it once. 3 call, that's 3. Let's see, that's 3 call. If you go with the n-1, 2. If you go with the n-2, that is 1. So if you go with the 1, so in that condition it return 1, right? In that condition it return 1. And for the 2 it call 1 and 0. 1 is already returned 1, and for the 0 it returned 1. That is my question. Let's see, in condition if the n is lesser than 1, then you have to return 1. So for 2, let's see, for 2 it return So now check it once. If you go with the DP of n, it return n-1, n-1, that is okay. You just add it, n-1 plus n-2. If you go with the 3, it call 2, and if you go with the 2 or 1, it return 2. It return 2. So 3 call 2 or 1. 2 plus 1, that is 3. For 3 condition it run 3. Let's see, that's why I'm getting 2 plus 1, that is okay. This is my solution, that is okay. If you go with the memoization, this is a memoization, okay. Now I have to go with the tabulation. How can be done through the tabulation? Let's see. I have to go with the tabulation part. First you have to create DP here, int DP of new int n plus 1, and DP of 0. First I have to calculate the from top to bottom, that's 1 DP equal to 1, and DP of 1 equal to 1, okay, for int I equal to 2. So already I've calculated the 2 value, DP of 0 and 1, so I have to start from the 2, right? And I should be go with the n and I plus plus. So then after we have to go with the DP of I means in I means 2. So in that one DP, take it once. First I will calculate for the tabulation part. Tabulation. So DP first, and that is a 0, that is a 1, that is 2, and that is 3. So now DP of 0, this is 0, and DP of this is a 1 index, that is 2, and this is 3. So now check it once. In 0 I have to go with the 0. Let's see, dp of 1, no, dp of 0 equal to 1, sorry, and dp of 1 equal to also 1. Now dp of 2 will be assigned with dp of I minus 1 plus dp of I minus 2, and then after we have to return dp of n. Check it once. So dp of 2 I have to calculate with the dp of 1 and 0, that is 2, and dp of this one I have to go with the 2 plus 1, that is 3. So what is the n here? Tell me, what is the n here? N equal to 2. So I have to return dp of n. So what is your dp of n? dp of 2. And what is the dp of 2? That is 2. So dp of 2 is 2. So it returned 2 for that answer. Same in tabulation part, it also returned dp of 2, that is there. This is my answer. Okay, now that's why I will take one extra data box for that one. So now we can run it. No. So I have to go with the condition. Here I just forget to add the semicolon, and here we have to write the condition. If n is greater than equal to 1, then you return 1. This is my tabulation part. And check it once. So I solve this question with tabulation with 100%, it beat 100%. So tabulation is far better than memoization. That is there. And thank you for watching my videos, and subscribe my channel. That's all. Okay, bye for now.